An ancient alien object is hurtling toward our sun at tremendous speed. Over the last month, Earth's most sophisticated telescopes have all been trained on this peculiar light traversing our sky. Scientists have been searching for explanations, but their observations have only generated more mysteries. The window of opportunity is closing rapidly. Before long, the object will vanish from sight, obscured by our sun's brilliant glare, leaving us with an enigma that demands resolution. What exactly is this phenomenon? In scientific terms, it's designated as 3I Atlas, which translates to the third interstellar object, signifying that it originates from beyond our solar system, from one of those distant stars visible in our night sky. The precise origin remains uncertain, but evidence strongly suggests that 3I Atlas hails from an exceedingly ancient region of the Milky Way galaxy, from a remote solar system potentially twice as old as our own sun. This marks only the third occasion we've successfully detected one of these interstellar travelers. The inaugural discovery was Oumuamua, that extraordinary cigar-shaped stone that tumbled through our solar system in 2017. Its true nature remains largely unknown, but its peculiarity was undeniable. Early indications suggest 3I Atlas may prove even more enigmatic. The second visitor was 2I Borisov, which has become somewhat overlooked as the middle discovery of the trio. This is because it exhibited notably conventional behavior. Borisov resembled a comet, behaved like a comet, and almost certainly was exactly that, albeit a comet originating from another stellar system, which remains remarkably fascinating. However, 3I Atlas has rapidly emerged as our most promising chance yet to examine a truly peculiar extraterrestrial object. This represents one of those circumstances where increased knowledge only deepens the mystery. According to official records, the object was first identified on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which inspired its designation. During that initial detection, it was positioned between the orbits of Jupiter and Mars, though considerably nearer to Jupiter. Subsequently, however, we've discovered that 3I Atlas was actually first captured on May 7, 2025, by the Transiting Exoplanet Survey Satellite, commonly known as TESS, which was occupied with searching for distant alien worlds. Consequently, it failed to recognize our new visitor at that moment. When that initial image of 3I Atlas was captured, the object was still traversing the space between Saturn and Jupiter. This information also provides us with insight into the remarkable velocity of this object. When NASA dispatched the Voyager probes on a direct trajectory toward Jupiter, the journey to reach the planet's orbit required between 18 and 23 months. We have confirmed that 3I Atlas was in Jupiter's vicinity in May. It is currently passing Mars in September and will achieve its closest solar approach on October 29th. By next spring, it will have returned to Jupiter's orbital distance. This velocity confirms definitively that we're dealing with an interstellar object. It's traveling far too rapidly to be captured by the sun's gravitational pull, a trajectory classified as hyperbolic. What makes the TESS observation particularly intriguing is that even when 3I Atlas was located beyond Jupiter's orbit, it was already displaying considerable luminosity, and then its brightness intensified dramatically over the 3-week period during which TESS was able to monitor it. This behavior is somewhat unusual, or at least unusual compared to the comets we typically encounter. Generally, these comets are substantial chunks of frozen water mixed with various rocks, dust, gases, and other materials from the outer reaches of the solar system. As that frozen mass begins its approach toward the sun, it heats up and starts to melt. In the vacuum of space, this phenomenon is technically termed sublimation because liquids cannot exist in a vacuum. Therefore, the ice transforms directly into gas. This process creates the large, bright, fuzzy envelope surrounding the comet, scientifically referred to as the coma. This distinction is crucial because our typical water-ice comets don't become warm enough to sublimate and form their coma until they traverse Jupiter's orbit and begin approaching the asteroid belt. Yet when TESS first observed 3I Atlas on May 7th, the object was still situated far beyond Jupiter on the opposite side. Nevertheless, it was already exceptionally bright and growing brighter daily, suggesting that sublimation had already commenced. Based on this evidence, we understand that if 3I Atlas is indeed a comet, it differs dramatically from any comet we've previously encountered. It's even radically different from Oumuamua, which was notorious for exhibiting no discernible signs of sublimation whatsoever. No coma was observed. They represent opposite extremes. It's also distinct from 2I Borisov because Borisov performed all the typical behaviors we would anticipate from a comet. Its strangeness lay in how familiar its behavior was for something so extraordinary. As we continued monitoring the approach of 3I Atlas throughout July and August, it continued to display increasingly bizarre characteristics. The coma surrounding the object began developing a tail, which is standard comet behavior. However, the tail forming around 3I Atlas started extending in the incorrect direction. It was pointing toward the sun. We recognize that the sun serves as the primary source of illumination, heat, and energy throughout our solar system. But we must also conceptualize the sun as resembling a massive fan. It continuously expels solar wind. This solar wind typically sculpts a comet's tail. The solar wind pushes back the rapidly expanding cloud of gas and dust surrounding the ice chunk to create an elongated trail. It's comparable to when a dog extends its head out of a moving car window and the airflow pushes their face backward. It's quite endearing. Now imagine if the dog extended its head out and their face stretched forward instead. That would be completely illogical, correct? That's precisely why astronomers were perplexed when it appeared that 3I Atlas's tail was forming in the sun's direction against the solar wind. These represent just a fraction of the numerous questions astronomers were attempting to resolve when they decided to direct the world's most powerful space telescopes directly at 3I Atlas. This includes Hubble, James Webb, SpaceX, which is this extraordinary cone-shaped satellite dedicated to studying the universe's origins. Additionally, TESS was redirected to conduct a second examination of 3I Atlas. It was NASA's most sophisticated observatory that provided the most valuable insight thus far into 3I Atlas's true nature. Once again, we've obtained some answers, but also encountered new questions simultaneously. The most significant discovery was that the coma enveloping 3I Atlas consists almost exclusively of carbon dioxide, which indicates that this object is not a large chunk of water ice like the comets we're accustomed to observing. Though it does contain some water, the ratio of CO2 to H2O measures 8.1, which essentially means there is 16 times more CO2 in this object than what you would expect to find in a typical comet. The carbon dioxide cloud surrounding the object is now estimated to be enormous, with a radius extending up to 300,000 kilometers. That's nearly half the diameter of the Sun. It's substantially larger than what we projected based on those initial observations in July. This has also led observers to speculate that the solid object at the cloud's center might be considerably larger than initially estimated. Initially, we theorized that the core of 3I Atlas might measure up to 20 kilometers in width. That estimate was subsequently reduced to perhaps 11 kilometers. However, based on these recent observations, the actual size could potentially reach 46 kilometers across. That's substantial, though not exceptionally massive. We've discovered comets within our own solar system with cores exceeding 100 kilometers in width. But the enormous quantity of CO2 relative to the minimal amount of water is unprecedented in our observations. It's essentially the inverse of what we would anticipate finding in a comet's halo. Consequently, it reveals that this object was formed in a stellar system with vastly different raw materials than our own. The compositional ratios are entirely anomalous, which is what renders 3I Atlas so authentically alien in character. But was it manufactured by aliens? There was another peculiar discovery made this summer during an observation of 3I Atlas by the Very Large Telescope in Chile. Yes, that's its actual designation. It's genuinely enormous. In any case, the VLT was able to identify the presence of nickel metal in 3I Atlas's coma, but it was unable to detect any trace of iron metal. Confused? Excellent. Iron and nickel are naturally occurring partners. They rank as the most abundant heavy metals in the known universe. This is because they are synthesized in the cores of dying stars and subsequently expelled into space by the force of supernova explosions. It's spectacular. Because of this relationship, iron and nickel are invariably found together in cosmic environments like AST. No one can state definitively what's occurring with that discovery. Therefore, you cannot conclusively rule out the possibility that it's an artificially constructed alien spacecraft. Again, it's probably not. But this is precisely why scientists and astronomers are urgently attempting to learn as much about 3I Atlas as possible within the limited time frame available to us. We have an opportunity to photograph this object as it passes in proximity to the planet Mars in early October, coming within approximately 28 million kilometers, which remains quite distant but close enough for 2 European Mars orbiters to obtain a reasonable view. The European Space Agency will deploy both the Mars Express and ExoMars Trace Gas Orbiter to observe 3I Atlas using high-resolution cameras and color imaging systems. It's not that we'll obtain a stunning close-up image or anything of that nature, but there should be sufficient resolution to distinguish between the gas cloud surrounding the object and whatever exists at the center of that cloud. Consequently, we might potentially gain some understanding about the object's actual shape. Then by late October, from our perspective on Earth, 3I Atlas will pass behind the Sun, and we won't be able to observe it again until December, at which point it will be departing the solar system. However, we'll have one final opportunity. On March 16, 2026, 3I Atlas will fly past Jupiter at a distance of 53 million kilometers. Still quite distant, but we do have one active probe stationed in Jupiter's orbit. It's called Juno. It's a veteran spacecraft. It's been operating in the Jupiter system since 2016, and the probe's scientific mission is actually scheduled to conclude in September 2025. NASA had been planning to simply crash the probe into Jupiter for disposal and observe the results along the way. However, an alternative end-of-life mission C would be to attempt intercepting 3I Atlas as it exits the solar system. As bizarre as studying this object has been so far, we're not finished with it yet. There's still an abundance of information to uncover. We will obtain answers, will likely also generate an equal number of new questions, and that is precisely what makes this entire endeavor so exciting.